Maybe we can start. Good afternoon, everyone, and a very warm welcome. My name is Sadesh Gandhi. I work with ENTSO-E as a Senior Innovation Specialist. We are very much excited to have you join us for this discussion focused on the important role of digital twins in, in transforming our transmission and distribution systems. I'm also joined by my colleague Omar from DSO Entity. Omar, would you also like to say a few words?
Yes, thank you, Sidesh, and welcome everyone. Good afternoon. My name is Omar Warkaya, coming from DSO Entity, and indeed we will be co-hosting with Sidesh the whole webinar. So today's event, it's a collaborative effort, as you might all know, from the DSO and TSO community. So we are bringing important conversations all together, and we expect to be of such interest for you all. Coming back to you, Sid.
Thank you, Omar. So we have a packed agenda with insightful presentations from all expert speakers. Each expert speaker brings unique perspective and deep expertise in their respective fields. And we are very much looking forward to all the valuable presentations as well as their insights. Very quickly, let's run through what we have planned for you today. We'll have our opening keynote delivered by George Ponescu from DGNR. Following that, we also have Urosh Salubir, who is the chair of RDIC at ENTSO-E, and Flor, who is the chair of DSAP at DSO Entity. Both together will present strategic vision for digital twins in transmission and distribution. Then Omar, together with Rishabh, will provide an overview on the Joint Task Force, some insights on the results from our study, report on challenges and gaps in digital twin implementation. And after this, we will have a broader presentation and a panel on breaking organizational and technological barriers, featuring various experts. And this will be followed by spotlight on case studies and use cases from both TSOs and DSOs. Finally, we'll have Anna, who is the chair of DSAP from ENTSO-E, as well as Flor, to discuss the road ahead. So what are the required measures, the ongoing work on use cases and roadmap. So that's pretty much in a nutshell the agenda for today. If I move forward, so some housekeeping rules. We'll be using Slido tool throughout the session for any questions you may have for our speakers. Some basic rules. Participants are muted by default. Speakers will be asked to switch off their audio when not talking. Participants, as mentioned, they are invited to post their comments, questions on Slido, and the webinar is being recorded. So both the video as well as presentation will be made available to all the attendees after the webinar. So with that being said, we would like to get a better sense of who has joined us today. So we're using Slido for a couple of quick interactive questions. So please navigate to Slido on your devices, and you may enter the code, event code DSAP. I see that the results are coming in. So let's wait maybe 1 minute. Great. It's fantastic to see that we have a diverse representation here today. Definitely strong showing from DSOs, TSOs, and then we also see a good mix from technology providers, research, academic institutions, and then we also have some participants from other areas. So we have consulting, advisory, and energy supply. Great. Let's maybe move to the next question. So we would like to know what is your primary area of expertise or the department within your organization. Yeah, let's wait maybe a few seconds here. So far, R&D and innovation, IT management and digital transformation. So definitely this sets a perfect stage for our discussions today. And then we also see a good mix from operations, control systems, data analytics, grid planning, and development. Great. All right. Thank you all. This definitely gives us a better understanding of the collective knowledge in our virtual Teams meeting room today. And with that, we can move to the next part. So it's time for our opening keynote, which will set the stage for our discussions today. And so it's my great pleasure to introduce George Ponescu from DGNR. George will provide some insights on EU action plan for digitalizing the energy system. George, thank you for being with us. The floor is yours.
Thank you, Siddesh, and thanks ENTSO-E and DSO Entity for inviting me today. I'm George Ponescu. I work in the European Commission, the Director General for Energy. And indeed, just a few words of the policy background and what happens behind the scenes of the triggers, the actions that you'll hear about today. Now, moving to the next slide, please. We are all aware of the profound transformation of the energy system and the challenges that is bringing, but also the opportunities. So we have massive changes at the edge of the grid with consumers of all sorts getting very active, interacting with the grid in ways that were not possible before. We need the backbone of the energy system, the electricity grids to remain in good shape and continue to drive the energy transition and the electrification. And we fully witness the 3Ds, which are the decarbonization, decentralization, and digitalization acting in all this. Next slide, please. This is why to look at the digitalization, the digital aspects, the Commission published a couple of years ago the action plan on digitalizing the energy system, which looks both at the opportunities of this transition, looking at new ways of facilitating the exchange of data for the energy system along the energy value chains, to promote the investments, to bring benefits for the consumers, but also looking at the inherent challenges like cybersecurity and increased energy consumption. But for the purpose of the discussion today, I will focus on the area which is highlighted there to promote investments. Next slide. And here in the action plan, we have two key actions. And one of them is to work on developing digital twins for the electricity grids. And this is the part of the landscape that I wanted to put you in the picture with. So immediately after the publication of this action plan, we had a very good development, the commitment from the TSOs and the DSOs to work together and to implement these actions. And it was created a joint task force, but you'll hear more about this in the next slides. Just a couple, just go back a bit, please. But to complement this, there are also two European funded projects that are ongoing. One is a large project that will demonstrate different concepts, implementations, architectures, and so on for the digital twins. This is the Twin EU. And the support project to help the DSOs to engage with the process and help them to reap the benefits. It's the DSO for DT. Now, what was the thinking before all this? Now we can go back to the next slide. Of course, these projects, the joint task force, they have their operational, they have their general objective, the more operational objective, and you'll hear more about those. But behind all this, the intention was both process-wise and content-wise. So process-wise, to bring together the critical actors, a critical mass of organizations to create a common vision on the digital twins for the grids, to align the views on technical matters. And as we are about to hear, this is not easy at all to conceptualize and clarify taxonomy of use cases, to look at potential reference architectures, what are the system services, and so on. So all the detailed technical discussion that we'll have the pleasure to hear more details in a bit. But also to consolidate, to bring people together and have the communities of practice and facilitate this knowledge sharing. And then looking ahead towards the results, the view is to stimulate the innovation, to bring everybody together to facilitate the problem solving in all this. And very importantly, to facilitate the decision making once we move towards implementation. Of course, there are different implementations already of the digital twins, but once we crack this nut into more details, we were hoping to sort of alleviate the implementation risks and the difficulty of taking the financial decision to invest in such instruments, and have this on a wider scale. And ultimately, of course, with the view to create the economies of scale and have a resource optimization, not to reinvent the wheel in each organization and have tiny, sort of very customized, highly customized solutions, but to have a critical mass of common things that could be reused and have more off-the-shelf products. And finally, for the discussion of today, next slide, please. But this is mainly food for thought, but also for the next steps, and primarily for the task force that's driving this, to launch now the discussion, to start the discussion, what will come next. The roadmap for the digital twins is already hitting this important milestone, and we'll see the results today. And then until the next of the year, the end of the year, there will be other remarkable developments. But what comes next? We'll have a blueprint. How can we implement it? What would be the next steps? Who would be the main actors? What would be the commitments of these actors? What is everybody set out to do? This is one point of reflection that will need to happen in the near future. Then not to lose sight of the, let's say, the buzzwords of today. Of course, the AI has been in the energy, the more classical operational machine learning for quite some time now. Now we have the generative AI impersonation of these AI tools. Can we use this in what way, shape, or form and incorporate it in the digital twins? And then it's important to think from now how we continue the cooperation that's being started. Of course, we are, let's say, at the beginning of this cooperation, but it's important to continue thinking how will stay in place, because we see that it brings benefits. And ultimately, what would be the policy support that would be needed? So for the implementation of such a blueprint, we'd like to hear, as I said, some commitments of the main actors of what to do. Probably there will be need for further public and policy support, and we'll be delighted to hear from you sooner rather than later, as the Commission is will start to prepare very soon a strategic roadmap on digitalization and AI in energy to be published early next year. So if you have great proposals to on how the policy support would apply to this action, we would like to hear from you soon. As I said, these are a few points to keep in mind for the next, let's say, strategic steps. But now I rest here, and thank you.
Thank you very much, George. With this, I think over to you, Omar.
Yes, thank you, Sidesh. Indeed, very insightful remarks from the Commission. Thank you, George, once again. Now we will move into our strategic vision on the digital twins for both transmission and distribution. And here we will have our co-chairs. At one side, we have Uro Salovier, who is the Research Development Innovation Committee Chair from ENTSO-E. And on the other side, we have Flor Patra de Lon. She's also the chair of our Digital Task Force DSO at DSO Entity. So to start with, I will give the floor to Uros, please.
Thank you. Do you hear me?
Yes.
Okay. So in terms of joint task force, I have to say that Anna is our co-chair, and she will come with her position quite early on in this event. But I will take a few positions from the ENTSO-E research chairing position in order to maybe break the ice from the ENTSO-E side for the TSO. So maybe I will take one word from George introduction, and I really see that he also sees that decisions which we take are really important. And I would like to point out that in this kind of energy business environment, it's all about decisions. We have long-term decisions, we have short-term decisions, we have some reversible decisions. We can include some generation unit in and out in system operation, but we also have some irreversible decisions. When we, I don't know, invest into something, we usually don't just destroy those assets. We have some information-based decisions. We have some experience-based decisions. So good decisions, which of course we want to do always require knowledge of the environment. Now I'm moving from decisions to the environment. This environment in which we are working, of course, could be, for example, an offline database. We get some study, we get some papers on the table, or it could also be some SCADA system, a simulator, or what is now more common and the most powerful environment description is called the digital twin. So this is how we get into the digital twin environment. Now, decisions are by definition taken through the environment by the agents. So when you have a digital twin, you cannot just deploy the digital twin without having an agent. In the past, the agents were people. So usually the decisions were taken by people. But now we are moving more and more towards more sophisticated agents. That means semi-automated supportive agents or even automated agents. And this is how the whole story about the digital twin is enveloped in these different elements of the sophisticated new paradigm. So what we are doing here with this digital twin environment? So we definitely see that we are entering a very challenging times. We see that operational challenges are getting higher and higher. All the energy transition is bringing, of course, the operational people and investment teams, and that also means the industry players into a new level. So we have to be prepared for this new level of action. This is why I will start with this more operational control related digital twins and the actions which we need to take there. So we need to be ready to identify more complex patterns, more correlations, more trends that humans cannot easily discern. So I'm not talking directly about the event in Spain, which recently took place. I'm actually talking about future brownouts, blackouts, events which have a huge tendency to happen. You know, we cannot simply say that we are bulletproof for any event of the future. We have to get ready for those things. And even if nothing would happen last week, we would definitely need to look into this kind of environments and events. And we have to be ready that we will not be always able to identify these complex patterns in the future just by humans. So this is why we need more sophisticated tools to describe environments, but also to get into the hands of these decisions, which need to be taken in this new environment. And these decisions sometimes can take some time, but sometimes needs to be taken very quickly on a short-term basis. Another level of decisions which I see in this new environment is related to the planning in terms of how we call it grid resilient planning. When big events happen, we can be prepared for it in different ways. First line of defense, of course, is to prevent them. The second line of defense is to have some redundancies, which will somehow help us keep the lights on in a bigger system. But the third line of defense is that even if everything falls apart, our grids can act and keep acting in a sort of resilient mode, which means that we keep the most important services alive and we still do not cause any harm to our societies. But we have to look really, really deeply into this because it's not such an easy exercise. Involving the resilience element into our common grid planning is something just beyond the common wisdom that we have today. So we have to look into this from another dimension, and the TSOs have decided to put this into the priority of our exercise for the digital twin. Very important part. So resilience in combination with operational tools is really something we are looking forward to. The third element of this exercise is related to consumers. Usually we start with that part, but today, because we are just so influenced by the events going on, I will put them on the third plate, on the first place. And here, I think we just need to be aware that that this kind of consumer engagement, this kind of active participation of consumers is still waiting for us. We still haven't done enough to get consumers on board of all the actions, all activities, all the planning. And at the end of the day, the consumers will be impacted by our decisions in this way or another, through the costs, through the security, through the reliability of service, through the quality of service. But active engagement of consumer, of course, is a very hard issue. And we don't know exactly what is missing there. We know that consumers are not so easily attracted into the services. They're not so easily attracted into the operation or planning of the future grids. But we want to go that way. We want to have consumers on our side, and we want to know what is missing there, what needs to be done, what kind of incentives, what is the amount of incentives that needs to be taken, or what is the digitalization behind this activation, what is the real challenge that we are facing there. Of course, we have some very efficient and active schemes of consumer engagement, but we need to go for mass penetration of these technologies. So TSOs are extremely ambitious about the digital twin work. We really see huge benefits or even urgency to work on this. And we are really looking for the deliverables through this common work. which will supply all the missing ingredients for the future digital, I would say, challenges that we will explore together with the DSOs, together with the European Commission, and together with all the stakeholders which need to be involved in this extremely challenging exercise. So thank you for listening, and I will stop here.
Thank you, Uros. Thank you very much. So now I would like to give the floor to Flor. Please go ahead.
Yeah, thank you, Omar. So thanks, Uros, for the introducing words. I would like as well to thank George Pandescu for these opening words. And I gladly note that coincidentally, the issuance of our joint task force roadmap could usefully feed into the work on the strategic roadmap on digitalization. So that's a kind of a milestone we will keep in our mind, for sure. In this joint task force, I would say that we have been working for the last 2 years, and I would like to say thank you to all our colleagues from TSOs and DSOs, because this joint task force is quite of a unique space for cross-fertilization and co-creation on this topic, and to share expertise, good practices, and also exchange views on strategic and technical matters. There is surely a deep common view, which is that clearly digitalization is not optional anymore. I think Uros just explained very well about the context we face. We are in a transition time. I think you said a word about urgency, Uros, and we need to be prepared for the next level, more complex patterns, more uncertainty. And this transition is good, I would say. It's both a challenge as well and an opportunity for grids operators. In this acceleration, DSOs have a very much more active role to play. Observability might be, especially at lower voltage level, still a challenge for many DSOs. But for sure, once we have data, they need to be turned into actionable insights and value for our operations. In that respect, from the internal survey we conducted, so I think so we will get more deep dive on that in the next presentation. There is some general conclusions I like to point out. The first one is that I think there is a large consensus that digital twins is a pivotal and instrumental technology. This technology, I would say, from what we got from our TSOs and DSOs, is advancing rapidly and reshaping the way we manage the grids and overall the energy systems. Second, we could observe as well that DSOs and DSOs have or are developing many deep performance digital twins in many different kinds of application areas, both in network operation. Uros stressed the need for better activation of flexibility. That's certainly one of the most prominent use case we have seen across DSOs and DSOs, but also in smart assets management, in better planning capabilities, and so on. And last but not least, I think so what we shared as well is that digital twins can serve as one comprehensive technology for leveraging data from various data sources. I admit that at that point, that the sample of this service might seem a little bit limited. So because we got 25 DSOs, 15 DSOs at the end, we are very confident that at the end it will provide solid foundations to design a roadmap towards scalable and interoperable solutions. That being said, and I will finish on that, for all the discussion we have been having in the last 2 years in this joint task force, that's clear that we face also lots of challenges. The first one is clearly interoperability, seamless integration across legacy systems within companies, but also to establish a scalable and robust pan-European federated network whenever needed is very key. Second, the model is as good as the data you have, so data quality is crucial. I think that's a kind of no-brainer, but it has been stressed many times in our discussions. Similarly, modeling assumptions are key parameter, and the model is as good as the assumption it relies upon, and assumptions might be dynamic as well. It should be kept in mind. Fourth, implementation complexity. So adopting a digital twin is not a plug and play exercise and requires, as you know, significant initial investment in time, resources, and technical expertise. So I think we will get some deep dive on that in the next session. And last but not least, that's about business acceptance. Changing end-to-end process usually requires as well to change organization, to break organization silos, way of working, to establish clear data governance, to conduct robust change management, and at the end to enhance the digital literacy of the workforce. And to overcome all these challenges, obviously, this joint task force is a unique space, I would say, and that's crucial that we continue collaborating together, DSOs and TSOs, and to have also contacts with external stakeholders. I stop here as well, and I'm sure we will get more further detail and insightful details on all these different challenges and issues in the next presentations. Thanks for your listening.
Thank you, Flor. Thank you very much to both of you, because indeed the words that you mentioned indeed set the direction for what the Joint Task Force is working. So now let's move on into the next section, where we will present an overview of our Joint Task Force on digitalization. And here we want to present some challenges and gaps for the implementation of digital twins. Here I will present together with Rishav Vandia, coming from Tenet, the Dutch TSO. So I will start giving the overview. Yes, this slide. So to give you a bit of an overview of the Joint Task Force and how this collaborative effort has been structured. So on the high level, you would have the Joint Task Force that is co-chaired by both associations, ENTSO-E and DSO Entity. At one side, on the higher level, we have the Commission, the European Commission, for which we try to keep very close contact, try to debrief and update on the direction and the developments of the project. On the other side, we also have the Advisory Board. These Advisory Board are comprised by various companies and associations coming from the industry, from research institutions, and project initiatives. Basically, the Advisory Board for us, it serves as a reality check of the developments that we are doing, and contrast with the actual developments that the industry will require or is developing as well. So to find common synergies and perhaps common approaches whenever feasible. Internally, both associations, ENTSO-E and DSO Entity, organize their members, because as Flor has mentioned, we have a variety of members coming from different countries, both sides, TSO and DSO. But for us, we have certain internal processes that would ensure that the developments that we are working on will be applicable across member states at the pan-European level. So the idea for us is to ensure this endorsement and ensure that every development or concept that is being developed within this project might be applicable at any local conditions that other countries might face across Europe. If you move into the next slide. Yes, so to give you a bit of a glance of the timeline that we are expecting, the project now runs through its second year. Here we already have some deliverables issued that are publicly available, of course, but our work, it's organized in different working packages. Here, what we aim to have by the end of this year is a strategic roadmap. Will highlight certain guidelines for the development of digital twins in application of transmission and distribution system operators. If you move into the next slide. So how do we see the Joint Task Force digital twins? So if we start with the definition, we can understand that digital twins as a whole has a broad definition, and the definition would be to have different versions of a virtual replica. It's either from a physical asset, it's either for a geographical environment, it's either for a combination of assets, where you might, where the process might entail simulations, data gathering, data harmonization. There are different features and applications that might bring a digital twin alive. But from our point of view, we don't want to narrow down the whole process of digital twins into one single definition. What we want to do is focus on what are the aspects that would enable on that or will bring added value to system operators at all levels to make it function and to make appealing enough for its implementation. So one aspect that we take into that we consider within the digital twins is that these solutions are data driven at all times, because whatever it's applicable, it relies on the data that it's being inputted. So it's fair to say that the effectiveness of these solutions will rely on the let's say quality of the data that is considering. On the other side, and how it has been mentioned already by Uros, it would have certain capabilities. And one of the aspects is to have these predictive capabilities towards grid conditions. For us, understanding the limits of predictability is very important, but also to understand whenever it's not possible to predict or forecast any grid conditions, we have to run into certain scenarios that are relevant for the future grid behaviors. And another aspect we take into account is the life cycle management of the different assets that are considered in the digital twin. So the digital twin can also be used on planning applications or asset management or maintenance operations. So it will have different applications, and it has to consider the different characteristics of the assets that are tried to simulate. If you move into the next slide. And now jumping into how we separate or categorize its applications. So we have defined 3 different clusters for our workforce. One cluster, it's mainly focusing on the consumer-centric components of the digital twin applications. So what it comes with the business requirements, with certain data exchange requirements, the market that it will interact, and we'll also try to integrate consumer behaviors in the future, especially with sector coupling activities. If we take a look into what the cluster 2 it's working on, our cluster 2 looks into the future, how the planning strategies could be replicated and assessed within a digital twin solution. Of course, this will take into account what are the future flexibility requirements, and of course also understanding what is the life cycle of certain assets for a better planning. And the last cluster, cluster 3, focusing more in the operations, dynamics, control rooms of the future, and the resilience of the grid, more close to real time or operational planning time. So this is how we try to organize our efforts, but it's just to say that we don't see digital twins as a nice to have tool, but we rather look into the actual benefits that it will bring for the challenges that TSOs and DSOs already see or will see in the near future. So now I will give the floor to Rishab to continue with the presentation.
Thank you, Omar. I'm Rishab Bondia from Tenet TSO, the Dutch transmission system operator, and I work as maintenance strategist in asset management department. So as Omar highlighted the 3 clusters we had made, we did a survey to find what are the challenges from the perspective of TSOs, the DSOs, and from there we try to extract common challenges and make some major containers or points which we should address through DSO. So if we look at the TSO challenges, so from the cluster 1, which is the data information exchange, business and market perspective, it's the data interoperability across Europe, and then increasing or improving the coordination in the connection, curtailment and tariff process. So from TSO perspective, if you look at it, that different countries inside Europe are connected, and we need to have better coordination, and also the data we collect, it might be inspection data, it might be operational data. The interoperability will help us better manage the grid. But at this point, it is a challenge for us. From the planning and assets life cycle and future for flexibility perspective, we need to increase the resilience in extreme conditions. And for that, maybe we need more high quality meteorological data for better predictive analysis of equipment performance and equipment health, so that we can have the high resilience and high reliability. From the system operations, dynamic and control room of the future perspective, there is no particular challenge as such, which is deviated from the common challenges which we will talk about in a bit. Now, if we look at the DSO challenges for the same clusters, yeah. So from the customer's business perspective for DSO, of course, it is more focused on empowering the customer, giving it or involving it to for better data access, and then also simulate more incentives to have flexibility. From the assets life cycle and planning perspective, there has to be a better connection management, better management of the connection requests, and harmonize the planning process. And then there's also creating a comprehensive register for multi-term planning across different sectors. If we look from the system operations perspective, then it's more about establishing clear observability zones for the high voltage, medium voltage, and low voltage networks. Now, using both of these perspectives, if we look at what are the common challenges we have seen, so definitely we need to have better control and observability of interconnected devices across different kinds of voltage levels. Then enable the online services and better data access for the consumers and also third-party applications which we might use. And that will automatically also imply that we have seamless interfaces to enable that. From the planning perspective, the grid modeling should be quite comprehensive so that we can correctly analyze the impact it can have on different grid operations. And then also the expansion of the renewable energy sources and the control of it is something we need to tackle in future. From the system operations viewpoint, accurate forecasting because of the fluctuating load and shifting generation is a major challenge. And then also the high impact, low probability events or cyber attacks and these kind of new critical elements which can make the grid vulnerable should also be monitored and actively managed. So if we look at the 6 blocks we have made based on this analysis of the challenges, then definitely data quality, because the better the data quality is, we can have a better situational awareness of the grid. Then interoperability for better control and coordination, transparency of the grid operations, some new roles and responsibilities which will come with the changing grid. The non-compliance with EU regulations, we have to be sure that we are compliant with the regulations. And then we have multiple stakeholders, and that stakeholder management has to be governed. So these are the main 6 blocks of common challenges we have identified across TSOs and DSOs. If we go to the next slide. So we also did in the survey to analyze what is the maturity level of different TSOs and DSOs on the application areas. So maybe I can take an example or two to go a bit into deep. For example, if we take system operation and operational planning, so the digital twin in this context or application area is in the maturity level D, which is more in the diagnostic phase, and which also fits in how we look from the TSO perspective, that for better system operation and better planning, we need to focus on predictive analysis and diagnosis of the grid. And that's why the digital twin activities are at a much higher maturity level compared to, let's say, then if we go to grid flexibility and customer interaction. These are still at the early stages of development and integration, or if we look at data platform, data exchange. So this also shows where the priorities of the TSOs and DSOs lie, and which are more important and critical areas for digital twin activities or developments to address. And that's why it's mostly focused on real-time monitoring and control, building the information model and the 3D modeling and system operation. And the rest of the application areas then will catch up in future. If we go to the next slide. So what are the measures and the next steps we take from the perspective of the 3 clusters we have created? So from the customers, business, market and data cluster, we have to develop more capacity maps, improve our interfaces, and also the digital platforms we are building, which can be in different level of maturity, needs to be boosted for more grid flexibility and increase customer interaction. We need to also expand. I think I finish and then I come to your questions, Jesus. So then we need to expand the integration of the data, have better analytics, and coordinate to have a harmonized exchange of protocols, so that then everybody is aligned on how we are monitoring and observing the grid. We then also need to scale and standardize. Right now, digital twins, we are still not having enough standardization, so that is needed, and integrate use case according to the grid and the markets. Looking from the planning and assets lifecycle perspective, we need to adapt the European standards and also implement dynamic asset rating as we go more towards data-driven planning and maintenance and replacement. Similarly, here we also do grid capacity maps development, enhancing of interfaces, and also the scaling of the platforms, what we also do for cluster 1. But here we do it more from the optimizing the hosting capacity. The digital twins we create, they need to be interoperable, and the scaling needs to align with how we do it for the BIM and the 3D modeling. If we look from the system operations perspective, the next steps would be again to scale and improve interoperability of the digital twins, which is also what we do for the cluster 1. Then for system operations, we need a good TSO DSO coordination for decision support and control room activities. So there we need to work on that. And then, of course, we have to also enhance the grid and market modeling through the scaling through new use case integration, and also standardization of the data from the forecasting and data aggregation context. So yeah, this was what I wanted to present. Maybe I can take the question from Jesus.
Sorry, Rishabh. So we don't have Q&A for this session,
Sorry.
but I invite all of the participants to post their questions on Slido, and I also invite all of the speakers to respond directly using Slido.
Okay.
Just for information for everyone, so the report on common challenges and opportunities for digital electricity system has been published on both ENTSO-E and DSO Entity, and you'll find more information about the results and insights in the report. So with that, I would like to thank Rishabh as well as Omar, so for both providing an overview on the structure of the joint task force, as well as Rishabh to you for providing much more the results and the key messages which are coming out for each of the clusters. So thank you both. So if I move further through the agenda, so for those of you who are just joining, we are now moving into a really crucial part of our discussion today. So focused on breaking organizational and technological barriers. And for this session, we have 4 distinguished speakers who will share their insights and experiences on how to navigate these barriers. And after the individual presentations, we'll open up for a panel discussion. So please keep your questions coming through Slido. With that, I think first we'll hear from Professor and Dr. Ulf Hager from VDE. Ulf will be focusing on interoperability of digital twin solutions. Ulf, we are keen to hear your perspectives. Over to you.
Yeah, thank you very much, Sidesh, for the introduction. So here I will present some results that we have from a VDE working group on digital twins in power systems in Germany, for which we also try a lot to have the discussions also on international level, like for example here in this group. And so the focus here on what I want to present is that nowadays classically a lot of digital twin solutions are still, let's say, individual solutions. So like bottom-up approaches. So where we have single digital twins for some single use cases. But nowadays we want to go more towards end-to-end processes, definitely, so that things need to be linked with each other. And in that way, we go more and more towards the concept of federated digital twins. So where those individual digital twins need to be linked. And if we look at that from the organizational perspective, then we definitely also need to go more from top down then, because linking things also needs to have the overall perspective of the organization. If you could move forward to the next slide, because then I would like to discuss with you about standardization and operability for such a federated digital twin. And if you want to link 2 systems, then we can talk about the distance to bridge between those systems, and that depends, or let's say that can depend on the standardization. And I want to discuss with you how. So we definitely mentioned, let's say, in the previous presentations that standardization needs to be further developed so that will be able to link our digital twin solutions. But I want to discuss with you now how far it needs to go, and because there is so if we reduce the distance to bridge between 2 systems by improving the standardization, then of course the systems work better together. But if we think that we also have further digital twins or systems that we would like to link, then also of course this reduces our flexibility, and also it increases the risk for creating further silos. So that means what we would recommend is that we need to develop the standardization in a way that it covers all the things that are relevant for let's say in total for the groups of systems that we want to interface, but it should not cover all individual things which are very specific and different between different systems, because then we get this difficulties that I mentioned. And then so therefore a good compromise is really important here. And furthermore, if we go towards plug and automate standards, let's say the lowest level here, then it's just really important that digital twins or that they should be open and free of use for digital twins. Then when talking about interoperability, that would be the next point, then it's always very common that we work with the smart grids architecture model. And here it gives us several layers that we need to look at. So we have let's say from top down, we have the business layer, the function layer, which is more, let's say, on the level of the organization. And then we go further down towards information layer, communication layer, and down to the component level, which is very individually and technical layer. So that means for the interoperability, we need definitely to consider all those layers, but we need to have different knowledge depending on which level we are looking at. And on the lower levels towards the component level, we need a lot of technical level knowledge. And on the higher level, we need domain knowledge. And for that reason, so I want to discuss with you, so where does, let's say, the manufacturers have their knowledge, and where is definitely also the knowledge of the grid operators necessary. And we think that on the technical, so on the lower levels, component level and so on, that is really where the manufacturers bring in a lot of the technical knowledge. But in order to bring the twins together somehow on the domain level, on the higher levels, there we definitely need the knowledge of the grid operators, because to let's say to bring systems together, this is not a thing which can be done, let's say, by individual or by constructing individual twins like in silos, like what usually is coming, let's say, from many manufacturer sides. But here, really, the domain knowledge is necessary, let's say, inside the grid operators, and bringing it towards the manufacturers, let's say, as constraints somehow of the products, so to support that those individual twins can be integrated on business and functional level. So that is the points that I briefly wanted to introduce, and I hope I have covered my 6 minutes, or not covered, but not overextended.
Thank you, Ulf. Thank you very much. I think all of those valuable insights into interoperability, which is truly a foundational element, is something we need to solve. And with that, I think I would like to introduce all of you to Dr. Andreas Strasser from Austrian Power Grid. Andreas will be addressing the topic on digital transformation for unlocking the full potential of digital twins. Andreas, the floor is yours.
Yes, thank you, Sudesh. You can hear me, right? Perfect. Okay, so thanks, Ulf. You have mentioned the federated digital twin, where we will connect individual digital twins together. And that's the reason why the digital twin will be an organizational game changer. And when we are looking on the left side, so here we see a system operator with typical departments like the finance, the asset, the system, and the management. And let's think about congestion management, and you identify you have some kind of limitations, and then you decide that you want to build new power lines, new substations, and so on. So then you go to the asset department, and they will plan the new substation, the new power line, and they will use specific digital twin methodologies like the building information model. And in the end, as a result, you will get a digital twin of your new substation and of your new power lines. And with these results, then you can go to the finance department, and there you have the enterprise resource planning. And the enterprise resource planning is a digital twin as well, because here is the information about the market, the prices, the availability of the supplies, and so on. So the whole supply management, but also other parts. And with the information from the building information model, you can calculate different scenarios, because if you can stretch the timing, then maybe it gets cheaper to build your new substation. If the timing is very strict, maybe it costs a little bit more. So you see, as a result, you will get different pricing results. And with these scenarios, you will go to the management, and the management will decide what is the best optimized solution for building the substation and the power line. And what we have seen here, that each department has its individual system and their individual digital twins, but in the end you are all connecting them together, that the management can take the best decisions. And that's also where you can see here we are building up this federated digital twin. But before you can achieve such a nice process, you have to think about these end-to-end processes. And we all know if you have different tools, then it's sometimes very hard to connect them together. And that's the reason why, especially at the beginning, when we are trying to build up these federated digital twins, corporate development and change management is a key and very, very important. On the right side, we also see that when we are connecting more and more systems together, and let's say we are connecting them directly together, the problem is that it is not working linearly. So for example, with 5 systems, and if you want to connect them all together, you will have 10 interfaces. So you see it is exponentially and not linear. And so the problem is with more and more interfaces, also the required engineering effort is increasing. And that's the reason why classical engineering processes, they are struggling with that huge amount of integration. And therefore, there are other methodologies, especially the system engineering processes, which were designed to handle complex big systems. And the big question that arises for system operators is, are we still in this classical engineering processes part, or are we already achieving the system engineering processes? And in my opinion, the system integration will lead to more complexity. And if we want to manage this effectively and efficiently, we need to have this comprehensive view and analyze it using this system engineering. Let's go to the next slide. The good part is that this kind of transformation, so we will have a transformation from a classical system operator to a system developer. We are already inside of this transformation, and there are other domains who already manage that one, like the automotive domain. And what we can see here, the original equipment manufacturer, they are building the car, but as we know, they have a lot of suppliers and so on. So they need to think about what do they need to, what kind of requirements do they give to their suppliers. So they are focusing on the system engineering, and the other ones can concentrate on this engineering. What I see currently is that many TSOs or system operators, they think, okay, now we need to program our own software, we need to make our own tools and so on. But the problem is, in the end, somebody needs to think about the whole digital grid we are building, the whole system we are building. And so to be future-proven, it is very important to understand that we are at this highest point, and we need to think about how can we connect all these individual systems together as a whole, and also analyze the cascading effects. Please, next slide. Okay, and so what do we need to change? So we need to look at the methodologies, and we need to build up skills. So first of all, implementation projects regarding the digital twins are not really technical implementation projects, it seems like at the first place, but also there are a lot of organization development projects. And grid operators require additional interdisciplinary skills, which must be developed internally. We need to have this digital mindset, we need to have the system thinking, the system engineering, we need to focus on data management and interoperability, system safety is key, and also the testing and quality assurance. Of course, you can also implement digital twins without these skills, but the problem is this will result in medium and long-term technical debt that needs to be solved at a later stage. And if we want to build up these capabilities, and if we want to successfully implement them in our companies, it is important to understand that this will take a couple of years, and it requires a profound change in the organization. So change management and cultural change is the key for that one. Okay, thank you very much.
Thank you, Andreas, very much. I think with that, we can move to our third speaker in this segment. So we have Christoph Prosinski from TEN. Christoph will provide us insights on more of a utility view on digital transformation, more from the DSO perspective. Christoph, we look forward to your presentation.
Yeah, hello everybody. Thank you very much for this opportunity to talk about the organizational challenges of implementation of digital twins. As you all might recognize in your organizations, I had a chance to make a drawing of a generic DSO in Europe. We have data sources and data users which need to be connected to create a digital twin. We have achieved a standard digitalization process in the normal way, but we have still challenges to connect all the data sources to the data applications or users. As you can see here, I illustrated this by a confusing point-to-point interface mix, where we have inconsistent interfaces, different technologies applied, different ages of the technologies, and all these technologies also need certain knowledge which we have to keep handy in the organization. So that means also a challenge in the generation of the engineers, the so-called aging society. On the other hand, we have an increasingly data-driven decision-making nowadays. We have an increased data volume, and we also have increasing reporting requirements. And all these systems we apply today are mostly legacy or monolithic. So the structure of the data is another challenge. We have different data formats. We have also offline data and online data and stuff like that. And all this needs a bit of a rethinking and redesign of the organization and how to work together. Would you please flip to the next slide? My approach is to insert a master data repository, which might be a digital twin, or a database, a single source of truth, or however you will call it, to connect the data sources and the data users. We still have the same needs, so nothing changed, but this master data repository is introduced, which helps us to manage the data and to connect data sources and users. We can structure the data inside this repository in a certain way to have a consistent company-wide management of information. And this introduces new chances to reduce the maintenance effort, and the validation and correction of the data is facilitated. Another chance is to create vendor agnostic systems. That means that you can choose your supplier. If you're not happy with a supplier, you choose another one, and you just change the solution, the application, and the data set is still there and in your format and in depth if you need it. Please slip next slide, please. Another thing to consider is the organization itself, where the people work in the departments. My vision is to enable a new central business function, the provisioning service for a digital twin, which connects all the departments, and there are certain needs for data and applications. To have a good organization, you should deploy data stewards, a person who is responsible for the data quality, the formats of the data, and you can also use canonical data models to support future applications which you do not know now. Of course, you have to work with data standards, so everybody uses the same format and it gets streamlined in the process to implement new functions, business models, use cases, and so on. And one last slide, please. We have to show. This will take a while, of course, and we can imagine this as a step-by-step approach where you start with a digital documentation in the beginning, you add sensor data, later on you have actuators which can get used to build active systems which react to certain things. And if you add stochastic information or analytics and decision support systems, you can also create systems which might in the future, in the distant future, also be highly automated or even autonomous. That means if you build a digital twin now, you should consider all these steps in the future that you are able to implement new applications and therefore have the functionalities and services ready at hand in the future, and you do not have to start again. So thank you for listening, and I'm happy to discuss with you about more of the details. Thank you.
Thank you. Thank you, Christoph, for that focused outlook from a DSO perspective and also the journey of digital transformation. And last but not the least, in the series of our presentations today, we have Stefan Kilp from T&D Europe. Stefan will broaden our view by providing perspectives on the overarching theme of our topic today, which is breaking organization and technological barriers. Over to you, Stefan.
So hello to all. What is needed to ensure a proper governance of large-scale interoperable projects? So we have to consider 3 pillars. So the first one is the technical and IT infrastructure pillar. Ideally, this is aligned cross-sector, but it has to be at least aligned per sector. Then the second pillar is the governance, means rules, roles, processes, and legislation requirements. These items should be aligned for the sector, but they can be specific to use cases. So finally, the standardization and exchange formats and protocols. This should be aligned as well for the sector, but can be as well aligned only per use case. So this separation into these 3 pillars helps to get a structured discussion. Further, to facilitate the digital transition is to apply change management principles, like the communication of the why and what goals have to be applied. As probably many processes have to be modified, the awareness of digital requirements has to be fostered. So next slide, please. So digital twins create a supporting environment over the whole life cycle. So means from planning to construction, further to operation, and finally to recycling. But to get these benefits from the digital twins, you need to make sure that you have to put in place the foundational functionalities, which means that you reach a good level of observability and controllability in your grid with installing interconnected grid components and sensors, actuators, etc., and software. So these foundational functionalities are the base for the system functionalities, like balancing and flex use case, for example. Finally, foundational and system functionalities are the ingredients for the business functionalities, like planning and operation in digitalized electric grids. So next slide, please. So I would like to introduce to you a good practice from other industries, the Asset Administration Shell, in short AAS. The Asset Administration Shell has been developed in the context of the Industry 4.0 and is today a proven concept standardized in IEC 63278. It's a digital representation of an asset, means a digital twin, which provides a standardized way to describe data and functionalities in so-called submodels. Basically, you can consider as a container for data which can be identified over a unique identifier. With this asset administration shell, you can cover the full life cycle of an asset from planning over operating to recycling. You can enrich the digital twins EAS with data from different life cycle states, like for example for operation. And identity and access management is ensuring full data sovereignty, means access to public and restricted information can be decided by the data owner. The Industrial Digital Twin Association, who is accompanying the development of the asset administration shell, is providing, for example, many standardized templates, e.g. for the digital nameplate or digital product passport, and is also developing new templates, e.g. for flexibility data model. So you see on the right-hand side, the what I would call a container of the asset administration shell with a different, what they call submodels for the different functionalities. So in different colors, you see in gray is a public available data, and in orange you see, for example, the flexibility data model as a restricted submodel. To summarize, the EAS concept is an existing concept which can be easily adapted to the use in the energy sector. So thank you for your attention.
Thank you, Stefan. Thank you very much. Once again, a big thank you to everyone, all of our speakers for those insightful presentations, each tackling a critical dimension of implementing digital twins and overcoming associated barriers. Now, I would like to invite all of the 4 speakers, including my colleague Omar from DSO Entity, for a panel discussion. I think we've received few Slido questions so far. We'll try to get through as many as possible, but meanwhile, we start with few questions for the 4 panelists. First question for Andreas. Based on your experience, what are the most persistent organizational or cultural barriers which are opposing the widespread adoption of digital twin solutions within system operators?
Yes, so I think, as I already mentioned before, one of the biggest problems is that in the first place, we are thinking that when we are implementing digital twins, it's more or less like a technical project. And the other side is that we also like to have fast lanes. And for example, last week I've heard from a system operator who said, oh, well, we have a geoinformation system and this looks like a digital twin. So maybe we can add all additional functionalities what we need inside of the geoinformation system. But the problem is, I mean, in the first place, you can start, but if you're not looking at these cultural aspects and organizational aspects, you have the problem that you're implementing there new functionalities, new data models, new data, meta information, and then suddenly the costs are increasing of the geoinformation system. Then somebody needs to maintain the data. Who is the data owner? So the problem is that all the problems what you were not thinking about at the beginning becomes bigger and bigger. And therefore, there is nothing like this fast lane. Even if you're thinking at the first place, this is just a technical implementation and we just want to add this small piece into your function. Ulf described before the problem that at the beginning, you're starting with this individual twin, but from time to time, especially when you're looking to these end-to-end processes, you identify, okay, now I want to connect this and I want to add another functionality, and you're increasing these technical depths. So for me, the best would be that in the beginning, you should think about, okay, who's responsible for what, who needs to be during the process, what could be organizational problems? Do the project managers have the capabilities inside of the companies, or is there any major barriers that they cannot be very successful? Because the problem is that in the end, if you are not making the ground for these organizational perspectives, and this can be just done from the top management, the project will fail. And the other side is also, if you're the project manager and you're more on this technical side, maybe you do not have the skills to understand what kind of organizational aspects are necessary, but it is very important to make the top management the awareness about these organizational aspects to have successful federated digital twins projects.
Thank you, Andres. Indeed, I think buy-in from the executive is something very important for majority of the digital transformation projects. My next question to Ulf. Often integrating legacy systems with new digital twin solutions is often a major challenge. Based on your experience, what are the top 2 or 3 strategies or lessons learned for achieving this cost effectively and with minimum disruption?
Yeah, thank you very much for this question. That's a really relevant question because we have, of course, a lot of legacy systems that need to be also included in the concept, because otherwise it takes decades until we really can fully utilize the digital twins. Yeah, for the legacy systems, in my opinion, the data quality is really one of the key issues, because the thing is, for the existing systems, depending on what you look at, it can have very different data quality. And also nowadays, the data or how to quantify the data quality is not always known. So for that reason, I would really recommend that when introducing such a legacy system into a digital twin concept, then at first the data needs to be, or the data quality needs to be somehow inspected and quantified. So that means probably nowadays the data is in several silos that could be, and even there can be inconsistent data. So that means this needs to be compared to the real asset, let's say, or the real device. And then, the errors need to be removed there, so that high data quality. But at the same time, you also asked in your question, so how about the efficiency, of course? So therefore, I think it is important, of course, high quality does not mean that every single data point needs to be of highest quality, but we need to specify what kind of quality we want to have. And then this needs to be documented in the digital twin as well. So even if we don't have the highest quality, because that would be really very difficult to reach, we can document the data, let's say, with a lower quality, but it needs to be then specified how this documented data, how the quality of that documented data is. So I think this is really key issues that need to be done in the initial steps. And let's say final comment, because why is this important? Because when we link digital twins with each other, we add more and more use cases there. And then maybe in the future, another use case, or let's say from another digital twin of those federated digital twins, is using data from another twin. And then that means initially when you set up that data, you don't know exactly what are the future use cases that it will be used for. And therefore, it's really important to have documented the quality also of the data.
Very interesting remarks. Thank you, Ulf. I think definitely there are these compounding effects of data quality if they are not handled from the start. So thank you for sharing those views. Over to you, Omar.
Yes, thank you, Sid. So I wanted to pose a question for Christoph. And we know that there are a lot of pilot projects related to digital twin, and sometimes they are not always coming into operational tools that system operators can use. But from your perspective, from your experience, Christoph, what strategies do you see in terms of organizational challenges or governance models that you think are needed to ensure that these digital twin pilot projects will become into a more sustained operational tools that can be used in the industry?
Yeah, good question. First, I think you need a strong commitment from the leadership in the organization. So on a strategic plan, you have to consider certain aspects, and you need the sponsorship of the executed level. So without this, you cannot secure a long-term implementation and adoption. Then, as I said before in my presentation, you need cross-functional governance. You have to consider many aspects of the company, the utility, IT and OT operations, power system planning, and also several tools like existing tools like ADMS, GIS, SCADA systems. And you have to integrate those pilot systems incremental, so use case by use case. So it grows in an, let's say, it grows slowly into a strong system where many applications are considered inside. Another thing is that you have to work with standards. And of course, don't forget the people. You have to develop the skills. You have to create a digital mindset and literacy in your organization and train the workforce who's using the digital twin in the end.
Thank you very much, Christoph. So I will now have a question for Stefan. And it has been slightly mentioned in terms of standards, but there is always the question about open standards and perhaps even open models that might be out there. But from your experience, Stefan, what do you see that could be a practical and significant benefits that system operators, but also the industry as a whole, can benefit when adopting open standards or open data models?
Yeah, so there are many benefits of standards and open data models. So, for example, it allows a seamless integration of systems and devices from different vendors and avoiding the vendor lock-in. Also, it simplifies upgrades. Then you have also reduced integration costs. So standardized models help to avoid the need for customized interfaces and data translation layers, which means basically lower engineering and maintenance cost, and also an acceleration of deployment of new technologies. Also, it concerns the improved data quality and consistency. So common data semantics, for example, ensures that all systems interpret data in the same way. So it helps really to get a common baseline. And then this will enhance decision-making accuracy and reliability of analytics and AI models. Finally, and it's not a full comprehensive list, also it allows faster innovation and deployment. So open standards foster a collaborative ecosystem where tools and solutions can be reused. And this accelerates the deployment of new applications like predictive maintenance and distributed energy resources management systems. So, and maybe to conclude here, so digital twins have in common that they have really a greater benefit when they are implemented within a digital ecosystem and embedded in such ecosystems. They share and can continuously enrich data throughout the whole life cycle. So there are many benefits, and as said, this is not a comprehensive list. So we can talk maybe for half an hour about the benefits of using digital twins and applying open standards and data models.
Thank you, Stefan. Yeah, indeed, the topic is very extensive. And just diving into one, it could take hours into our conversation. But now, for the sake of the time, we will take a few questions from the audience. There was one question related to the standards for data exchange related to CGMs. Perhaps this is a question that could be addressed by together Andreas and Christoph, because we understand that CGMs are standards that could be used for certain system operators more than others. But perhaps the question is CGM's standards, Common Green Model Exchange standards, considered to support digital twins. So from your side, TSOs and DSOs, how do you see?
Yeah, so from TSO perspective, the CGMS is a standard for exchanging power system models. So yes, of course, this every standard is supporting the digital twin, and especially when we want to exchange power system information. But I think it's very important to understand, okay, if I just have a data model or a data ontology, this is not enough. Of course, I need to implement it inside of a tool, inside of a system, and these data needs to be exchanged. The power system model can be used to derive the information from my physical power system into to digitalize it into a data model and exchange it to another grid operator.
That's the use case we do, exchange the CGMES files with our neighboring TSO. So he has a good view on our grid conditions in the operational department. And this works well. So if you have an established standard which is maintained by the community, why not use it? You don't have to invent the wheel again. It's very flexible. The CGMES profiles, you can extend them to your own needs. You can also consider several aspects from power system operation, power system planning department. And if you bring it together in this idea of a master data repository, you can also consider certain time steps on the strategic level, power system extension and so on. So yes, I would try to use the standard because it's widely adopted and not to use another one.
Thank you, Christoph. Thank you, Andreas. Maybe one more question as looking into the time, and that will be also posed to Ulf and Stefan, if you can both complement this one. So the question is, what is your approach? What would be your approach to legal and organizational interoperability? Like, for example, data governance, data protection, and licensing, according to Regulation EU 2024/903.
Okay, thank you very much for this question. So for the organizational, or could you please repeat the last part of the question?
Yes, I will repeat the whole. So what is your approach to legal and organizational interoperability? For example, data governance, data protection, and licensing.
Yeah. Okay. So for example, the inter-organizational interoperability, I mean, then we are, of course, pretty much depending then again on the standards. And I think there is several things. So on the one hand, if you are inside, first of all, I mean, you need to specify the things within your organization, because there you have already a linkage of a lot of different digital twins there that you need to do, and where you must specify how they can, let's say, work together. But then if we are on the level between several organizations, or let's say between organization and manufacturer, that is of course the next step then of digital twins that need to be interconnected. There, let's say, the standards get even more important, let's say, because there you cannot only specify, let's say, your own solution that is necessary, that can be applied inside your organization. And then also, I mean, we go into the field of data spaces, so that we can have common data platforms that will be necessary somehow to link those things. So I think that is my answer on this.
So I would complement this answer with saying, so you may remember my first slide, what I have presented, to have these three pillars to have the discussion about, for example, rules and roles here we need to really, basically, this is the rule book which you need to build up then in the technical infrastructure. So we talk then about identity and access management. So for example, I would promote here or advocate here to harmonize it on eIDAS 2.0 and European Business Wallet, to mention something, and to have a very common identity and access management, ideally over cross-sector identity and access management, so that we have one system how we manage the authentication and the authorization. And then, of course, as mentioned by Ulf, it's you have to consider the different standards to achieve the interoperability also per use case. And this is then very much dependent on what you plan to do. So maybe there is not one single solution how to implement it. So you need to check very carefully where you can harmonize it completely across the sector, or where you need use case specific solutions. So it's a very complex topic, but I think what is important from the organizational point of view is to have a very streamlined discussion by pillar, and then checking what is needed, for example, in terms of communication protocols to exchange. So it was mentioned CGMES. Of course, we should use existing standards and not reinvent the wheel. So here are a lot of different topics to be covered, and I think this is, of course, involving a very high level of complexity.
Thank you very much, Stefan, and everyone, for the questions, the relevant insights, and also your answers. So now let's move on into our case studies and use cases. I think you have seen so far on the webinar that we have touched upon the foundational aspects of implementing digital twins, organizational speaking or technological as well. But in this case, we will try to showcase a bit of what are the actual applications that are implemented across our members, both TSOs and DSOs. So if you can move into the next slide, please. Yes, thank you. So here we will have 4 speakers, 2 coming from the TSOs and 2 coming from the DSOs. At one side, we have Simone Cerchiara. I hope the name is pronounced well. He comes from Terna, our Italian TSO. On the other side, we will have Carolina Pluta. She comes from PSE, from our Polish TSOs. On the other hand, we will have Andrew Speck. He comes from Slovenia, our TSO LS. And finally, we will welcome Florian Schmickte. He comes from E.ON, our TSO in Germany. So to start with, can you go to the next slide? We will start with Simon, talking about TSO and DSO coordination at Terna. Please, Simon, the floor is yours.
Thank you, Omer. Good afternoon. Thanks for this opportunity to speak in this interesting panel. So to begin, just a little bit of background before the use case. I worked for Terna, and I'm seconded in Equigi. Equigi is a joint venture between 6 TSOs, is a fully regulated business, and is a platform. So we are a software company. Equigi was founded in 2020 with 4 TSOs joining as founding fathers. And in 2021 and 2022, we joined APG from Austria, and also Transalpia as a second TSO from Germany. The platform itself wants to create a data exchange and enable all the parties to communicate. So it's not overtaking the role of the balance service provider or the TSO or the DSO. It's just a technological tool, basically to connect the party together. You can go to the next slide, Omar, please. Yes. So in 4.5 years, this is what we've been doing so far. basically in the 5 countries where we are active. We did projects on balancing markets mainly and redispatch markets in Germany. In the Netherlands, we are today operational. So we did a lot of pilot projects in the past, but we are going live in more and more countries today, mainly in the Netherlands and in Austria with the product of secondary reserve, AFRR. And today, the use case is on TSO DSO coordination, which is the Italian pilot project, even though we did another one in Swissgrid as well. Yes, so in the process of the digital twinning or digital transformation, which is a part of it, Terna, together with the software provider Equigi, developed a software to optimize the data exchange. This data exchange is realized mainly with standard taken from EIC and ENTSO-E, already existing standards, documentation, and improved and enlarged with additional data. So we call it canonical data model. This TSO DSO coordination in Italy for Terna is based on a static traffic light and dynamic traffic light, which are basically 2 systems to exchange data between the system operator on one side, the distribution operator on the other, and the BSP. This is done through mainly APIs and also through a web UI interface. The DSO has also the opportunity to avoid grid congestion, declaring which part of their grid are in that moment not ready to be to take part of the balancing for example, AFR and MFR. The platform also provides data registry. There is, of course, a data governance in place, and the system operators, mainly the TSO, can utilize the database as a secure source to retrieve the data. And on the next slide, we see the multi-party system. So it's all about data exchange, of course. From one side, we have the consumer or the aggregator that onboards their device. We have the balance service provider, which places offers, flexibility offers, the market operator that can declare their constraints, and finally, a system of validation of those data, which is mainly based on technical validation of data. But in the future, with more visibility of the grid, we aim at also business validation. And on the next slide, we see a little bit more in detail. You can go already in the next one. Is a bit small. I hope we can focus. No, then the previous one, please. Yeah, on the left part is a bit small, but we have the registration and pre-qualification process. And on the right side, we have the bidding. So the static traffic light, which is the first exchange between DSOs, TSOs, and BSP, is realized by DSO utilizing the platform, declaring which of their resources cannot participate to the balancing market. This is done days and weeks before the bid is placed by the BSP. On the dynamic traffic light, on the right part, you have the day ahead, the day before the bid, a light that can be either green, orange, or red. The light is set up by the DSO itself, and that means that the BSP is not able to utilize, or is partially able to utilize, certain grid connection points in their grid. So yeah, to the next slide. Finally, we see the web UI. We have also a portal where basically the FSP can log in and can place their flex offer. They can download a template, which is based on ENTSO-E standard market documents for the bid. And then can receive also on the next slide, they can receive constraints and confirmation by the TSOs that the bid has been placed successfully. So this instrument is a very good exercise of cooperation between the TSOs and the DSOs, allowing also the BSPs to be aware what's the status of the grid in order for them to avoid grid congestions. So yeah, this is about it. Please feel free to reach out or ask questions.
Thank you, Simone. Indeed, very interesting use case. As you said, this is a TSO DSO, let's say, cooperation that in some cases it is already applicable for the system operator. So thank you very much for your presentation. Now we can jump into Carolina's use case, and this is related to a virtual reality model for the substation model. Here we can show you a bit what is being done in Poland. So Carolina, the floor is yours.
Thank you. Good afternoon. I will talk about virtual reality model for substation model. We have two types of model. The first one is virtual walk, which was created using around 130 spherical points. We use Godot engine to implement the substation, and in this way the panorama pictures were combined together. The movement of the switches was realized by cutting out from panoramas areas of different states of switches and assigning them signals for open and closed positions. In this way, we can for different positions. So next part for integration of the simulator. So the simulator is integrated with existing systems such as dispatcher training simulator Aristo, which is the core component of the simulator used for controlling objects, for collecting data, and for calculating network flows. It was developed by Swedish TSO Svenska Kraftnät, and it's a dynamic simulator which calculates new states every 20 milliseconds. And it calculates current, voltage, active power, reactive power, phase angle, and frequency. Other systems integrated with the simulator are a human-machine interface here. This is replica of real dispatching application. This is a replica using for maintenance staff, and another one, Windex. This is a real dispatching application for control centers. We also use backup panels of replicas of control and relays panels, which are on the substations, and these all applications and VR are connected to each other. The states of switches are read from a database in real time, and the real-time database can be defined as a data store. The switches, states of switches are mapped, and then the position of switch is changed in VR, and all of these applications. To show how it looks in practice, the VR workstation consists of a remote controller, a VR headset, and two sensors. On the video at the beginning, the substation employees came out of the control room. He went toward technological building, and now he opened control and relay panel for and he applied voltage, which allows to control all switches in this bay. In this case, this is transformer bay. He's going toward a high voltage switching station, overhead switching station, 400 kilovolts. He's checking position of the circuit breaker for each on 3 phases. They are all switched on, as we can see on the application here. and now he's going to open control and control cabinet and switching off circuit breaker. And now he's checking once again position of the switches. They are all switched off for each of 3 phases. He's going to open a control cabinet, which allows to control one specific switch in this bay. In this case, it will be transformer disconnector. And he will do it at master control cabinet. And now we can see disconnector movement in the background. And the change of state in application. Then he will open another disconnector in busbar bay, but at another control cabinet here. And we can also see a change of state in the background, but also in the human-machine interface here. This change is pointed with a remote controller. Then he can finally check voltage present on each of 3 phases. No voltage is detected, so he can close earthing switch, this one next to transformer. And he will do it in manual way using crank handle. But first, to use a crank handle, he has to deactivate a mechanical lock. And we can see a movement of earthing switches in the background. And also in human-machine interface, the change of states. And this is the end of connection activities related to grounding transformer. At the end, I want to briefly mention about second type of VR module, which was created using beam technology. And the area of the substation was scanned. We received in this way a point cloud. And the point cloud is a set of points in 3-dimensional space. So this is the same substation we saw in previous video, but in this model, the task is to extinguish the fire of transformer unit. At the beginning, user player switched off circuit breaker at the control cabinet in transformer bay, and then he went on to find fire extinguishers. So to sum up, the comparing virtual walk to project made using beam technology, the virtual walk allows user to move only at selected points, which is the disadvantage, but it reflects reality much more better and realistic. This all from me today. Thank you very much.
Thank you, Carolina. Indeed, it is very interesting to see how virtual reality could combine both electrical and geographical context to just use for different purposes. In this case, combining also switching features for field operators. So it is very interesting to which extent also the applications of digital twin can support different areas in the value chain of electricity grids. So now we will have Andres Peck. He comes from ELES, our DSO in Slovenia. Please, Andre, the floor is yours.
Thank you. Good afternoon to everyone. As Omar already said, I came from Slovenian company ELES, which is Slovenian combined operator. This means that we are TSO and DSO operator. I'm from the Strategic Innovation Department, which is dealing with digitalization and other strategic innovation things. According to our national legislation, we are also responsible for the development of the charging parks. This is development of the areas during the motorways where CPOs will be able to build fast charging infrastructure for the EV. Since it's quite hard to set into the landscape new objects, we start to thinking how to help with some tool that we will optimize the location of these charging parks. Since we noticed that there is uncoordinated development, there is no optimization between motorways and the TSO grid, and we want to push forward the development of those parks. That's why we decided to next slide, please. That's we decided to build digital tool, which aim was to make optimized to set optimized development of these charging parks according to the current grid status. This tool is deciding up to multi-criteria decision about appropriate location. First, our task was to collect the data that are already there. This means traffic flows, state spatial plan, spatial data, water protection or flood zones, heritage limits, agriculture areas, and all these data are taken into this digital tool. On the output side, we developed user interface for performing analysis, which are then used for the network development. Next slide, please. With this tool, DGLPROM, we are able, like I said, to make multi-criteria decision about appropriate location. We are able to make predictions of the traffic on the output for the future. And also connected to this traffic prediction, we are also able to simulate flow predictions in the grid. And also we are able to make some scenarios. This means if we add charging park at some point, or to add batteries, or if we add some production, what this means for our grid. Next slide, please. This is result showing according to the criteria which were set, for example, spatial data about local detail plane of the landscape, about spatial about slope of the terrain and other things. Where are the appropriate locations for the charging parks around our capital city? Here we see the ring around our capital city, and with red marked there are parcels where it's possible and where it's appropriate to build charging parks with very little infrastructure change in TSO grid. Next slide, please. We are planning to do also interface for the EV users. The challenge is integration of the results into our existing planning tools. We are also planning that this tool will be available for local communities in the end, that they will be able to check where it's the most appropriate and where can they build very fast without any reconstruction, with little reconstruction also in the distribution side, and they will be able to plan more efficiency and more in harmony with our grid, where the location of the charging infrastructure is most appropriate. We are also planning to integrate information about renewable production and also the price signals, and this will be converted then to the end users, and they will be able to choose when is the most appropriate to charge their vehicles. Thank you for your attention.
Thank you, Andrea. Thank you very much indeed. Very interesting use case as well in Slovenia, trying to combine sector coupling planning activities for EV charging facilities and combined with grid conditions and even market pricing as incentive. So thank you very much. Indeed, very, very useful and interesting use case. Now we will have Florian Schmichte. He will present, he is coming from Germany and presenting our intelligent grid platform case on E.ON site. Please, Florian, the floor is yours.
Yes, thank you, Omar. So also good afternoon, everyone from my side. Today, I will introduce how we are helping DSOs redefine the future of grid planning and operations through a digital twin approach in our intelligent grid platform. So as energy systems become more complex, integrating renewable sources and managing decentralized resources become essential. Then on the next slide, the traditional planning processes are under growing pressure. So projects are increasingly interconnected and leading to cascading dependencies across planning timelines. And DSOs face serious resource constraints and manual workflow compound those issues. And expert tools are used in silos, and there's a growing uncertainty about how future developments will impact the grid. In the medium and the low voltage grids so the medium and low voltage grids now require joint planning. Non-wire alternatives must be considered. So in short, our legacy processes aren't keeping up with modern demands. And therefore, on the next slide, let's zoom in one specific pain point, which is the grid connection process we are addressing. And the information shown here are based on a survey we have done with multiple DSO. So currently, connection processes involve many isolated and also manual steps across various IT systems. So from assessing responsibilities to running simulations, evaluating options, and achieving results. And each request can consume up to 8 hours of work. And tools like Excel, GIS, and grid simulation software are used in fragmented ways, which increase workload and error risk. Clearly, there is a need for a streamlined and integrated approach, and that's where our solution then begins. So on the next slide, you can see our grid hub as a basis, which brings together planning and grid operation. And it acts as a central digital twin, aggregating and synchronizing grid model data from across different systems like ERP, GIS, and customer portals, and aggregate them together via a data shipper in this digital twin approach. And then it can be connected via APIs with third-party softwares or with our internal applications, such as for grid planning, online connection check, and also grid monitoring for grid operation. So by unifying planning and operations based on a single digital twin, we create a shared and up-to-date understanding of grid conditions and capabilities. And then on the next slide, you can see that with our intelligent grid platform, the connection process can be fully or partially automated, and from transferring customer data, pre-analysis simulations to report creation and reservation management, it's all handled digitally and in one and the same place. And instead of hours, the workload per application drops to as little as 2 to 15 minutes or even 0 in some fully automated cases. So this improves efficiency, reduces errors, and also allows skilled personnel to focus on strategic tasks rather than routine ones. And when you go then to the next slide, as I said before, with this digital twin integration, the DSOs gain full transparency and control, and they can proactively answer critical questions from both perspectives, from the planning and from the operation perspective, which are becoming more close together. And those questions, for example, are where are the bottlenecks in my grid? What will the future grid demand look like? How do planned measures interact? And what's the actual criticality of grid assets? And these insights empower DSOs to make better planning decisions and also future-proof their grids and optimize both maintenance and operation strategies based on data sets. When you go to the next slide, the focus in this short presentation first was on the planning side, but also some outlook on the operation side. So the digital twin-based solution combines planning and operation using the same live data foundation, and with features like real-time grid monitoring and automated switching, outage management, and field data feedback, the DSOs can respond dynamically to grid changes, and the platform in general supports ongoing improvements in data quality and enabling continuous adaptation to evolving grid demands. And yeah, just to sum it up here, the digital twin-based IGP offers then a scalable approach for DSO to manage the growing complexity of the energy systems. So for the moment, thank you very much for the attention. And yeah, if there is time for questions, of course, I can answer those.
Great. Thank you, Florian, and thank you all of the other experts for the insightful presentations. I think we won't be having a dedicated Q&A, but I invite all of the audience members to ask their questions in Slido, and at the same time, all the speakers to respond to those questions on the Slido tool. With this, I would like to move to the next part, the road ahead. And so basically, we are moving towards the concluding presentation of our main agenda. And this is where we will dive into what are the required measures, the use cases, and the roadmap. So to guide us through this forward-looking perspective, I'm pleased to welcome two leading figures who have been central to all of the discussions so far. First, Anna, who is the chair of Digitalization of Energy Action Plan at ENTSO-E, and then Flor, who is also the chair from the DSO entity side. Anna and Flor, we are eager to hear your vision on the road ahead, so the floor is yours.
Thanks. I guess I start by giving a short presentation on what is ahead of us in this joint task force. So a SAGE, that's a joint project between DSOs and TSO, which should end by end of this year. So we are now reaching the last phase of the project. We are currently working on use cases still. I think it was said many times that everything should be use case based. So they do reflect business and grids needs, and there's a driver for any changes in system and processes. So we are working on that. We are now prioritizing the use cases in each of the three clusters which have been presented to you at the beginning of our discussion. And we specifically try to build up on the European funding Twin EU projects use cases, but not exclusively. And we will be looking next into the gaps and how we can cross-fertilize our two approaches. In the next phase of the project, we will develop a digital twin concept by, I think we should, yeah, thanks. Concept by identifying user, functional, and technical needs for the deployment of this digital twin solution and detail all major integration requirements. And then in the next step of the project, and that's going to be our final deliverable, we will issue a roadmap by end of this year, a strategic roadmap, and it will be a sequence of actions starting with immediate operational issues while building long-term goals. For instance, we discussed a lot on it, so for interoperability, resilience, and collaborative solution across stakeholders. So in a nutshell, this is what we are planning to do. But as said, so we are still working on the use cases and on prioritizing them. Thanks, and I will give the floor to Henna. And still there?
Thank you, Flor. Yes, thank you. So I would like thank you for this presentation, introducing our new workstream ahead of us. I mean, the use case and then, of course, the roadmap preparations, that this is the ultimate goal for this joint task force. Here, I would like to dive a bit more into some technical aspects that we see ahead of us, also providing challenges that we would like to address during our discussions, during our expert work within the joint task force DSO. The list here on the slide is not extensive, but these are the key points that we have already identified and that we will also address during our discussions. So as necessary measures to be undertaken to support the energy transitions, we cannot miss in our discussions the point of interoperability. Here we would like to emphasize that there is a strong need to build upon the existing standards, but also to extend them and complement them when necessary, because we see new challenges towards increased, enhanced interoperability. The goal would be to discuss, to provide a legal framework to support the enhanced standardization. And we see the strong necessity for a trusted framework or for further trusted frameworks for data sharing that would improve power grid, but with this strong assumption of respecting business sensitivities, ensuring security of critical infrastructure that system operators deal with, and also with complying with privacy laws. But also with interoperability, we also see a challenge within our organizations, both on TSO side and also on DSO side, how to make legacy systems interoperable among each other, but also with new applications coming into play, with new modules being developed and also deployed. So these are the challenges we are facing within our organizations in terms of more technical aspects. Another feature is also functional safety versus or toward cybersecurity, and all of that's taken into account towards better system resilience. Here we think that we have this opinion that we need to build up understanding what is the relation between cybersecurity that we all value, of course, and we understand its meaning, but what is the relation with the functional safety? By saying that, I mean that the focus here within our work, within our discussion, needs to be on system operations continuity. So we need to have the system simply running, that the system will not fail completely in the case of an event or an error. So we need to continue its operation. And here I'm looking at two maybe still emergent technologies or already proven to be successful and helpful for our challenges. I mean, digital twins and, of course, AI. So we observe that there is a common effort from system operators needed towards federated digital twins when needed, when necessary, when we identify the relevant use cases. So this is like a sort of anchor towards our new work stream. I mean, the use cases work stream that Flor has already introduced. But we also observe, I hope you have this impression today during the webinar, that there is a strong need for enhanced cooperation between manufacturers and network operators for the digital solutions. And also we can think about digital twins as a fantastic basis for creation of new AI applications to support the power system operation. And also AI comes into play. This is something that we are all interested in, already started working on. So how to utilize the existing standards, the existing experience on standards for dealing with AI applications, especially in the sense when we have some non-trustworthiness about these applications. But also, I think, like for AI, we are all interested with the use cases, the applications, which is true. But we also need to be aware how multidimensional the change is when we discuss AI. I mean that the AI applications will bring a profound organizational transformation, and we cannot silo that. So we also need to have it in mind when discussing AI adoption by system operators. And I think also, based on the experience that we have already gained here, interdisciplinarity is also crucial, because we are not only power system engineers, we also touch upon very much IT, ICT infrastructure. So we need also ICT experts also lawyers. So the aspects we are discussing here are multidimensional, so this interdisciplinarity should support us to tackle the challenges and successfully solve them. So next slide, please, Tidesh. And when we focus on DTs, which is the key of our discussion today, of this webinar, we think from technical point of view that the goal here is to have high-performing, high-capacity, and highly secure digital infrastructure. So we have presented here various challenges that TSOs have among their organizations. DSOs deal with them within their organizations, within their business as usual, but also the challenges that we have in common. And we are hoping for such emergent technologies like digital twins to help to solve them. But we also need to have always in mind that even though the technologies are interesting, fascinating, like DTs, AI, the first principle for system operators is their business needs, their business goals. They need to be provided that will be supported by these emergent technologies, but these goals are crucial here. So we need to have that always in the first place while working on further work streams. So this is why I'm introducing the use cases workstream as well here, because these use cases will be defined within the Joint Task Force DSEP with this assumption of having the business goals always in the first place. So working on DT use cases must be accompanied by protection measures to ensure cybersecurity, also functional safety towards enhanced resilience. And we also need to have in mind that new technologies such as AI may cause new types of unknown hazards that we haven't dealt so far with. And that may add up on top of that, like the risks that system operators have already encountered. So that would be some of my remarks, some of my comments. I think we are slowly closing the webinar. So Flor, I would like to now give the floor to you, unless Omar or Sidesh would like to add something.
No, Anna, I think that was it. That was a really good summary of all of the measures and the next steps we plan to take from the Joint Task Force. So thank you to you. And I give the floor back to both of you for the closing remarks, and then we will close the session.
Yeah, thanks a lot. So I would like first to say thank you to everyone, to the speakers. So I think we could get many insights on the different use cases, on the challenges, barriers ahead of us. Thanks to the audience as well and to the questions. As a closing remark, I think so we could provide some kind of glimpse into our current work and what is ahead of us. I hope you understand that we take it very seriously. We consider that digital twins are here to support grid reliability, while at the same time we need to embrace local specificities. I think it was stressed many times that developing new technology requires as well to strike a practical balance between innovation and safety and security. I would add on that one. I know that it was not really touched upon in our discussion, but equally important is that along with solving concrete needs, we need also to make sure that we have a viable business case for digital twins, alike for every technologies, and therefore adequate regulatory framework supportive innovative solutions are essentials for both TSOs and DSOs. And I like to emphasize again that, and I think it was already mentioned by Anna, to work on technology, especially on digital twin, requires some kind of ecosystem partnership. So we will continue working hard together with TSOs in this Joint Task Force and beyond, because we have our advisory board, and we are very confident that our shared efforts will be laying the foundation for a future-proof, more resilient and more resilient European energy system. I stop here. Maybe Anna, you would like to say a few more words on that. And again, thank you to everyone.
Yes, I would like to thank also from my side, first of all, for the participation and discussion today during the webinar. But I would like to also acknowledge the Secretariat support from both sides, Sidesh and Omar, because they really have done so much to prepare the webinar. That was really fantastic work, very professional, to guide us so that we get here with hopefully success and that you all enjoyed the event. But speaking of further work stream, as Flor mentioned, we are focusing now on use cases. I would like to acknowledge the experts that work within this work stream. As had been mentioned at the beginning of the webinar, we have identified 3 high-level use cases, like the 3 clusters that we are working within now. So the experts are highly engaged, and I'm sure that during the next event that we will repeat dedicated to use cases, you will find out a very interesting summary of the results of our workstream dedicated to use cases. So thanks for this engagement, thanks for your expertise. And I think that like this joint task force, DSO brings excellent experts from all the stakeholders. And here we would like to emphasize that this cooperation is crucial for us, because I would like to, probably some of you know my citation, but I really like this site of Hakon Borgen, the previous RDIC meeting, is that the statement that the future will not be just an extrapolation of the present. So like the future of energy system due to energy transition challenges will bring a whole new future, a whole new quality. So in order to tackle that, in order to fulfill our energy transition goals, we need to work together, not only within the TSOs community. No, we need to cooperate. TSOs, DSOs, and also other stakeholders, manufacturers, welcome on board for our discussions. So cooperation is crucial for us. So with that, I would like to thank you for your attention. Thanks.
Thank you. Thank you, Anna. Thank you, Flor, for a very insightful overview and the path forward. It is clear that collaboration, strategic focus on key use cases, as well as roadmap are essential as we continue this journey. Once again, finally, on behalf of ENTSO-E and DSO Entity, we want to thank all of our speakers who generously shared their time and their expertise. And a special thank you to my colleague from the DSO Entity, as well as my colleague in ENTSO-E. And finally, thank you to all of the attendees for your participation and for your thoughtful questions on Slido and dedicating your time to be with us today. And with that, we draw today's session to a close. So thank you.
Thank you, everybody. Thanks.
Thank you. Goodbye.
Goodbye.
Thank you for participation and discussing. Thanks.
Yeah, thanks
Bye-bye.
for the discussion.